Now, there is no need to do a set of the keys. Why? Because all keys in dictionary have to be unique. It's a bit like when you open up a dictionary physically, the word composite must be found only one time and perhaps listed alphabetically to aid searching, right? However, it will be strange if you open up a dictionary and actually find two entries. That would be strange, and that is not the kind of dictionary we like a lot. And similarly, in Python, all keys are unique. So whenever we refer to the key of value 2, we basically also are going to retrieve that value that is kind of uniquely associated to this unique key. So likewise, just like dictionary can extract only the keys and return to us a generator to generate out all the keys, we can also ask the dictionary to give us only the values. All right. Now, obviously, the dictionary has no obligation to list it in any sorted fashion. It will just conveniently pull out all the values. So don't expect it to be sorted based on the key value, based on the alphabetical listing, based on the numerical ordering, whatever it is. No expectation of the, how should we put it? No expectation of the ordering of the values. Okay, so when we do that, d1 dot values, we will get a bunch of values, and the values themselves are not necessarily unique. Just for the sake of showing this, we change the 5 mapping to the spelling 3, right? And it's okay, and when we print out the values, you notice that 3 gets repeated. So it's not really a set in that sense, yeah, because the repetition of the values, they matter to us. They do count. They do make sense, right? Unlike in a setting where they have to be unique. Now, items is also very commonly used, where item is like a list of pairs, right? So it's like a list of the key value paired together in a miniature tuple. This might look complicated when actually it is very useful. So in a for next loop, right, we are able to, if you push this dot items into a for loop, you will be able to step through two variables simultaneously. So it's a bit like for key comma value in dictionary one's items, like that. Yeah, because it will be actually a list of pairs. So the pairs, Python's for will be able to smartly say, okay, the 2 I will associate with k, which is the key. The spelling string 2 will be associated with the value, right? And in that order, not arbitrarily, just always in that order. So if that's the case, we can always make use of it and say print key is k and value is b, right? Okay. So very conveniently with a two-liner, we don't even have to initialize the values of k and v, just plonk in the dot items method of a dictionary in the for, and we do a listed loop variables, and that's very, very convenient. And we can immediately step through all the key value pairs once and all for all the key value pairs. So that's very, very complete and nice and simple, and that's really the power of using Python. We are in very few keystrokes, we are able to accomplish our intention in a very unambiguous, logically very clear way. All right. Then we can select, and we have tried that before. We can select not the third item, because ordering makes no sense, but rather the value associated with the key number 3. And of course, that's the English spelling. So we get THREE. We can add in, all right, add in a new key value pair. So the key is always in the selector here. We just shift it to the left-hand side, just like a list. So we are altering the dictionary, in this case, by adding a value, a key value pair called 4: spelling 4. So now D1 should contain 4: spelling 4, because we earlier on deleted the key value pair whose key happens to be 2. So we don't need to know the value, we just need to know the key. Of course, that's different from deleting D1 because if you ask what is D1, that's there. But if we delete D1, then D1 is gone. It's undefined. The container is destroyed. That's not even a container, and the label is not there anymore. So let's run it again. All right, so what's D1? D1 is redefined as this. And what was I trying to say? Oh, okay. So earlier on, because 4:4, the spelling string 4, wasn't there, so it gets added in. It is okay to say D1 square bracket 3, yeah? So the key exists. So if it exists, it gets its value, the old value, overwritten. So if we say this, all right, then the old value is being overwritten with capitalized 3, and that's fine. There's no error. Now, what if we say D1 square bracket 5? Clearly, we'll get the string 5, and that's fine. What if we didn't know that 5 is defined or not? For example, if we say 6, we thought 3, 4, 5, they are there, so 6 must be there, right? Of course, we could have inspected it, but what if D1 is 300,000 entries large? We wouldn't have been able to see anything. So if we do that, we'll get an error because the key is undefined. Now, one way to solve this is to think of using try and accept, right? But we shouldn't, because this is data-oriented. Data-oriented processing tends to be quite tractable. That means we can always inspect and check the data, whether it exists or not, whether it is having weird values or not, whether it exceeded the range or not. We can always check that programmatically. We don't have to use this try accept setup to indicate our sense of suspicion, our sense of lack of control. So let me now try. I'm not very sure. You can always be sure. That's what I'm saying. So how do we do that? Because I know that in data processing like that, it's very tractable. It's very sure thing. You can always check to find out. You can always use if to find out. And that's what happens when I know that is the case. That is the underlying principle. So I look up what are the methods that may support such an operation. So there is this get here, right? There's this get here. Now what does that do? Well, let's do a help and see. What's the meaning of d1.get? I'm sorry, what I mean was to help d1.get. I want to see some help instructions. It says get the key. Well, we can do that with square bracket, right? But it has this nice thing called default none. Default none. So that means that when I say d1 square bracket 6, there is no default. And if it's not there, the basic behavior is to give an error that stops your program, which is very drastic. But if I do a d1.get, that means try to get the key with a value 6. I mean, try to get a key whose content is 6. But if it is not there, then give me none, non-existent. So end up, well, it is a very graceful way to say, no, there is no spelling for 6. Just spell out non-existent, right? Of course, you could have given empty string or none or whatever it is. So for example, d1.get 6, nothing exists, so none gets printed, or none gets returned. All right, so what's the value of v? 9. And then we tried out defining the dictionaries D2 and D3. Basically, some simple experiments to say, well, if spelling in English is provided by the dictionary D1, why don't we have another dictionary that provides spelling for Malay language? So 3 is Tiga, 4 is Empat, and 5 is Lima. And we try another dictionary for Chinese. So D3 is 3 is San, 4 is Si, and 5 is Wu, like that. And then we are able to begin some sort of translation. At least, in this very limited setup, we can do some sort of a translation. And for now, we are printing it out. But with a bit of imagination, we can connect the words to a speech processor to read out the words. And that would be nice. You can imagine that if we key in the value 2, the digit 2, or rather the digit 3, and then setting the right language will make the right sound come out. And that's fantastically useful, right? And let's just see how it works. This all dictionary is like a bookshelf. It is implemented with, not surprisingly, a dictionary. So a dictionary, when you say EN for English, I want English dictionary, then you will take out this English dictionary. But if I want Malay version, I will take out this other dictionary D2, which is translating for Malay language. And if I want Chinese version, I will take out D3, which gives us the Chinese translation version. So right now, we can then select if we want 4 to be pronounced or written out in Chinese, we'll first of all say all dictionary, give me the Chinese version, and translate down the number 4. So what we get is 4, right? Which is nice. Suppose we say we want 4 in Malay. So we say all the dictionary, like this bookshelf, look for the Malay dictionary, and now translate the value 5. What is it? It's 5, right? So what is all dictionary? It's a key value, structure whose values are all dictionaries like this. So it's a key of value dictionary, of course, which contains key whose value is 3, key whose value is 5, and so on. Okay, so just give you a moment to think about how this works. And notice that the ordering, there is no guarantee that 3, 4, 5 makes the most natural sense to Python. And because ordering of the key value pairs, that means expecting them to be sorted in any way, is not a proper expectation. Dictionary data type does not have the sense of ordering, all right? Unless you extract out the keys and then sort them, or extract out the values and sort them, then that would be locally meaningful. All right, so whatever dictionary you have, the values make sense to you to be sorted, then you sort them.